Hello. Well, yesterday we talked about minerals and we filled out this note page right here. Today we're going to flip this over and do the back side of this note page. We're going to talk some more about minerals and how we could test and identify different minerals by using the different properties of the minerals. So first on our list is color. Now color is probably going to be the easiest one for us to notice, and I'll show you why right here. You can see all these different minerals that I have all have very distinct colors, right? So this one is kind of a tan color, right? This one here we can tell is green. That one is pink. It's a little bit hard for y'all to see. My camera doesn't look that good, but it's pink. This one here is kind of a brownish, grayish color, you know. This one is just a white, just looks white. This one right here is yellow, red, purple. This one looks gold. It looks just like gold, which makes sense because it's fool's gold. There we go. Now you can see it. Okay. And like this one right here would be black, I would say, right? Color's really easy for us to identify. It's just the color that we see with our eyes. Now the trick is color doesn't always tell us the correct answer for what a mineral is. So I'm going to show you what's happening, why I say that. So we look and we see three different colors right here. Now, first instinct, I would say these have to be three different minerals, right? Because they're such different colors. Well, the thing is, all three of these minerals right here are quartz. So we can see color. We know, well, color's color. I mean, pink's pink, purple's purple's white, white. But they're all the same mineral. So we can use it to help us identify, but we can't count on it all on its own. Does that make sense? Okay, I'm gonna put those back, and we're gonna write in here colors produced by the mineral's composition, and it's what we see with our eyes. So color is produced by the mineral's composition. So that depends on the different atoms and things that it's made of. And I'm just going to put right here, and I want you to, what we see with our eyes. Super easy, right? Just color. Okay. Next, we have luster. And luster, we've talked about luster before when we were talking about metals, nonmetals, and metalloids. So this should just be a refresher. But luster is how the surface of a mineral reflects light. So okay, so how the surface of a mineral reflects light. So if you can think back, I know it was a while ago, to whenever we talked about metals, nonmetals, and metalloids and the luster of it, or how they reflect light, we had two options first. So they could either be metallic or non-metallic. And I'm going to show you two examples here. So this one is pyrite. And let me focus just a little bit. Okay, so when I turn this in the light and my little flashlight right here, would you say that this is metallic? And you remember metallic means it kind of looks like it could be made of metal? Hopefully you said yes, because this right here to me is definitely metallic. It looks like it could be made of metal. So we'll say this one is metallic, and then let me get this one right here. So this is talc, and I'm turning it, I'm looking at it. Does this look metallic to you? Does it look like it could be made of metal? Not really. Not at all, actually. So this one we would say is non-metallic. So you got to come first. Well, is it metallic or non-metallic? And then we can come up with all kinds of other descriptive words. So let's look at the pyrite again. We would say this is metallic and shiny because the little pieces that are reflecting the light right there, they're really shiny. I mean, they're shiny. So that would be the luster of this pyrite. It is metallic and shiny. Okay, I'm gonna put that one back, and let's look at the talc again. So this one here It is non-metallic, so that would be the first part of its description for luster. And then I would say kind of waxy, and I say that because I see it and I can kind of feel it. So I would say this talc is non-metallic and waxy. Y'all want to look at another one? Let me pull another one over here. I just love my little rocks and minerals. So this is a piece of quartz. That's that white quartz that we were looking at. And does it look metallic to you? Not really. It doesn't look like it could be made of metal. So we'd say it's non-metallic. And then, oh, let me get my light stick back on. There we go. So it's non-metallic. And I would still say that it's shiny because it's reflecting the light. Can y'all see how it's kind of reflecting there? Metallic and shiny. It's pretty good. Or, ooh, this one right here is a good one too. So this is my halite. Does that look like it could be made of metal to you? No, it doesn't look like metal, does it? So we would say non-metallic. And this one, to me, looks like it could be a piece of glass. So the description here for luster would be non-metallic, glassy. See how it kind of reflects the light like that? Let me see if I can get it to turn just right for you. There it is. Did you see that reflection? Just kind of like a piece of glass. So I hope that kind of helps. I'm going to write down these description words here. So we're going to say metallic or non. Okay, and then down here we could put dull, glassy, shiny, oh, waxy. Pretty well any word that you can think of to describe how something looks, it might work right there for luster. As long as it's describing how light reflects off of it, that's a good luster. Okay, so hopefully that's a good explanation to you about luster. The next one we're going to talk about is streak. And what streak is the color of a mineral in powder form. Excuse me. Well, how on earth could we figure out the color of a mineral in powder form? Well, we're about to find out. I'm going to write that right here. Okay, so the color of a mineral in powder form, and sometimes the color of that powder form is different than the color of the mineral on the outside. So let's see right here. I have this piece of porcelain tile, and this is what we test the streak on. Okay, so porcelain tile, and let me grab one of my little minerals over here. So here's my pyrite again. I like this pyrite. I think it's pretty. So this looks, what color would you write down for this? I would say it's gold myself. So this is very definitely gold in color. Well, let's have our porcelain tile, and the trick to a streak test is that you put it on here and you rub it hard just one time. And I've had students want to just color all over my porcelain tile, and we don't do that. That's not appropriate. You take it and you scratch one time, and if you don't get a good scratch, you scratch in the same spot maybe once or twice. Okay, so now you can see my powder right there. Let me pull it up here. I want you to get a good look at it. Oh, there it is. Okay, so what color is that powder? That's like a dark gray, right? Well, look at our pyrite right here. That is definitely not the same color, right? So we've got dark gray powder and we have gold colored mineral. So the streak color is not always the same color that's on the inside. So I'll show you one that is the same color. Well, I think it is anyway. Here's some sulfur. Okay, this is definitely a yellow mineral, like very, very definitely a yellow mineral. So I'm going to come here and I'm just going to scratch it one time, and all kinds of stuff came off. Okay, well, there we go. You can see, hopefully, Let me get rid of that. The color of the powder form of sulfur is definitely still yellow. Okay, so that's an important thing, an important property to know about sulfur. So even if you look at the powder form, it's going to be yellow, same as the outside. Okay, I'm going to write down right here under streak that sometimes it's different. So can be So it can be a different color than what's on the outside of the mineral. Okay. Next, we're going to talk about hardness. So this is another property that we can test that can help us identify a mineral. Okay, so these different properties, we've got color, luster, streak, and hardness is another way that we can identify a mineral. And what hardness is it measures the scratch resistance of a mineral. It's a 1 to 10 scale, and the 1 is soft, and the 10 is really, really hard. Okay, so the scale that we use to measure against is called Mohs hardness scale, and we'll talk more about that in the days to come. But I'm going to show you just a couple examples of some things that we might use to test the hardness of a mineral. So I have a piece of glass right here. That's just a glass plate. I have a steel file. I have an iron nail. I have a penny. And I'm going to use my fingernail too. So we've got a couple other things that we could work with, but I figured I'd keep it simple today. So let's take a piece of one of our samples here, and I'll use this halite right here. I'm just going to pick two of our minerals, and I want to see which one is harder, well, than the other one. So I'll take this one right here is talc. And for talc, actually this one is the softest mineral that we can have anywhere. And we know talc is softest because we can scratch it with our fingernails. So let me push this in here. Oh, you see how that powder's kind of forming right there? I'm pushing, that's not my fingernail busting up. That is this talc. So talc is the softest mineral, and it's so soft that we can scratch it with our fingernail. So there's that example. Okay. Next, we can try, let's see, fluorite. Fluorite right here. I'm looking at Mohs hardness scale over there because I want to make sure I'm telling you right. And fluorite, it says, can be scratched with an iron nail. So we're going to try it real quick. I'm going to set it down, and I'm going to scratch it with my iron nail. And did you see that right there? See how we have that scratch on it? I'm going to show you one more time. Are y'all watching? So see how that, now we have two scratches in our fluorite right there. So it was scratched by an iron nail. So we know that talc is a 1 because 1 is the softest, and fluorite can be scratched with an iron nail. And looking at Mohs hardness scale, that would make it a number 4. Okay, I mean, I know it's going to be kind of hard. We're going to talk about it in the days to come, but we can test the hardness of these different minerals using different things, right? And we would use our copper penny and our piece of glass and our steel file all kind of the same way. I really wish you guys were here, or that I could find a way to get some minerals and stuff to you so you could test it out, because it's super cool. We're going to talk a little bit more about these minerals, and then I'm going to let you go. Other cool stuff about minerals. Do you know what scientists that study minerals are called? Take a guess. They are mineralogists. It's kind of fun to say. Try to say it with me. Mineralogists. So, scientists that study minerals They're called mineralogists. Okay, so I've had some students in the past say, well, why should we care about minerals? Why do we have to learn about minerals? And I never asked that question because I think rocks and minerals are fascinating. I think the way they grow are fascinating. What we can do with them is fascinating. They are awesome. And I'm going to tell you couple really cool reasons why I want you to be excited about minerals too. So the first one is that minerals help our bodies grow and stay healthy. So if you've ever looked, I don't have anything to eat in here because it's science lab, but if you ever look on the nutritional information on your food, you can look and you can see the fat content and all that. Well, if you read down a little bit, it'll have a list of the minerals and vitamins that you get from eating the food. Your body actually has to have certain minerals in order to stay healthy. So I'm going to write right here, minerals help our bodies grow and stay healthy. Okay, so next on our list would be how minerals affect our economy. So minerals are really, really important to our economy. And I don't know if you've ever heard of people like mining stuff. Well, they mine minerals, and a lot of them, I don't know if y'all remember the video that we watched on Vocab Day, the most what was it, the most expensive minerals or something along those lines. The rarest, that's right, the rarest ones. So diamonds, there's big money in diamonds. Those are really expensive because they're pretty rare. You might have heard of people wearing amethyst or topaz, rubies. All of these things are minerals. They're beautiful and there's a lot of money there. So they affect our economy by mining. Okay. And last but not least, minerals can tell us a lot about how Earth was created and how everything in our solar system was created. So I'm going to write that down too. So they help us understand more about Earth's history and the history of the solar system. Okay. So one final question for you down here at the bottom. Are minerals a renewable resource? Why or why not? So minerals are non-renewable. That means we will not be alive in order to see new minerals being made because they take a very, very, very long time to develop. So we're going to put non-renewable. So they're non-renewable because they just take way too long to form. So I will have copies of this note page and the one from yesterday and your vocab sheet all under the Files tab, Unit 9, Rocks and Minerals. If you want to, you can go print it out from there, or you can make you a note page that looks kind of like this one. When you do, I want you to take a picture of it and send it to me, and I will give you some extra credit for today, okay? Make sure you answer the questions below, and I think there might be a couple more videos for you to watch, just people testing the luster and the streak and the hardness. They're all pretty cool. So y'all are amazing, and we'll see you tomorrow.